Hey guys, thanks for stopping by. 4 years ago or so, I made this. This was the wood and metal prototype, a little bit of Lexan on there, prototype of the Artificer set. So I had an idea. All I had at the time was a table saw and drills and such set. So that's what I made. And this was proof of concept. You can see it's got a little bushing in there that you unscrew as the capstone placeholder. And making this is what inspired me to get Thanos, which is my snap maker. And then a few months later, I had printed and lasered, CNC'd this right here. This was version 1 of the Artificer set. It's had a little bit of deterioration over the years, but still in pretty good shape and good enough that I can still look at what I did in my design there and try and copy some of that. So about a month ago, I was coming home from a canoeing trip, and on the plane ride, I had podcasts downloaded. I had my Kindle with me, but instead I just stared out the window the entire time and I thought about improvements that I can make to this set. So in this video, I want to go over those improvements with you, how I kind of came up with them, how I took them from something that was in my head to design files on the computer to then print and prototype to have in hand and test. So if you think that might be interesting, stick around. I'll take you through the process. And if you learn just one thing, then go ahead and subscribe to this channel, because I have tips in almost all my videos, one way or another, to help you become a better craftsman, whether that's with tack, like the board game that I've chosen to obsess over, or whether it's making drawers, boxes, cabinets, doodads, knickknacks, things like that. So let's get started. And this is the design I came up with. When I got home, I grabbed a sheet of paper because that is the best way to get things kind of solidified a little bit, but not have to be so exact that you're ready to go into CAD, because you can waste a lot of time with a slightly incorrect product in CAD trying to make it perfect, when you could sketch it out and iron out a lot of those details before you have to get super particular about something. This main improvement to the Artificer set is a piece holder. The original design was kind of like a rain stick. It was just a hollow tube and then the pieces rattled around inside of that, except for the capstones, which were a part of the kind of securing mechanism on the end caps. I wanted something that fit the theme of the set, so I decided on magnets and screws as a kind of fastening mechanism. The screws would act as little posts, which would go into keyhole slots on the end cap. You would rotate that, somewhere between 15, 25 degrees, something like that. Just, again, the ideas were pretty loose in my head, and then on paper you can start adding dimensions to things and some general guidelines and parameters. And then when you get in the CAD software is when you have to be a lot more precise. So going through that process, it kind of helps me, and I mean, you guys can do whatever you would like, but this helps me to not waste too much time in CAD trying to perfect an idea that is not ready to be perfected yet. So after putting those things on paper, then it's time to get them into the CAD software. This is FreeCAD, and this is version 1.0, I believe, right now, and it is my preferred CAD software because it's free. And I've grown to like it over the years and learned how to use it, at least at a basic level. The first step in our design is going to be to make the ring for the top of the pieces, and then make the cup at the bottom, and then some sort of trim piece to connect the two. I'm going to run this at 5x speed, so you guys don't necessarily have to sit here and watch me struggle with some of the settings, and so that this is not just a video on the CAD design, but the CAD design is just the kind of opening stage of this process. I decided to add a trim piece to serve a couple functions in this design. One, it's going to align and hold those end caps together, and another is that it's going to hide the seam where the sheet metal meets to protect fingers, and also to make the assembly process a little bit easier. This means that I don't have to be quite as exact when cutting the sheet metal, because there will be this trim piece to kind of overlap the seam there, and so I can cut it a little bit short and it will still fit. While you're in your CAD software, it's important to think about these sorts of issues that you might encounter during later parts of the manufacturing process. And if you can, implement solutions at this stage so that you're not kicking yourself when you get to them in the future. And here you can see one of the problems with feature creep in a design. Since I've added this piece, I now have to make the mating side on the end cap and then do some other things, because while I change that one piece, it kind of cascades downhill, and I need to change other pieces that interlock with that bottom part of the end cap. So for the first part, I just align some things around for the keyhole slots, and then I begin grooving out the inside of the piece so that there's a cavity for that screw to travel, the screw head to travel into. When I get done with that part, I take a look at the model and realize that I might have some issues printing it without interior supports. And so my solution is to slice this model into two parts and then have almost like a lid that I can print without supports, and then an interior that I can print without supports, and glue those together, leaving some registration holes as the magnets in the center. Okay, so from CAD file to slicer and then onto the 3D printer. Print those prototype pieces out, and then once they're done, do kind of a dry fit. Everything looks like it printed successfully. I had way too many supports on one of the pieces, so I'll need to fix that in the next iteration. It was just a bear to remove them. And putting everything together, everything fits about how I thought. A little bit tight, but that's better than a little bit loose. And we have a completed ring setup. Here's another little improvement. I'm going from like 16th inch plywood to 1/8 inch or 3mm MDF for the scoring gear that runs around the perimeter here. And that's another kind of feature creep design where it is going to require changes to more than just the one part. And now it's back to the paper for a list of tweaks or improvements to be made on the second iteration. And here's what I came up with. So some things didn't fit. I want to reduce the amount of supports used, and then I want to add a little bit of flavor to the blank inside of the end cap. And then again, thinking about the assembly process later on, I thought it would be nice to go ahead and make a 3D printed template so that I can line up all my magnets on the board without having to measure each one. So after the paper, it's back to FreeCAD to implement those changes. I make the functional changes to the end cap first, and then I go in and add the flavoring. So I'm basically just tracing a sketch of the gear and then using that to kind of stamp the interior of that end cap as a decoration and also an instruction. so that you know that the pieces go there. Kind of a little pictogram there. And then it's time to design the template. It's a very simple, just a right angle template with a hole for the drill bit. And with those designed, it's time to slice them, send them to the printer again, and see how our second iteration looks. Quick tip for working with magnets, especially these small ones. These are 5mm by 5mm cylinder magnets, and they're hard, especially for my hands, to hold. So, a couple options. If you have feeler gauges, you can stick the magnet to those. Just make sure it's a gauge that you're not using for actually doing its job, because it's going to get a little bent up, it's going to get a little super glue on it, things like that. Another option, if you have room to move, is going to be to use one of these putty knives here, putty knife scraper. Not sure exactly what your local hardware store will call them, but something like that. And then another thing that you will really want to do is keep track of which side is going into your material, which side's facing out. So what I like to do is, let's say that I am applying a magnet into this hole here, and I know that that hole is going to match up with my magnet on the side of the board here to help hold it when it's rolling up. So stick your magnets onto where they're going to go. Then you know that what's facing away from here is going to be what goes inside your material. And then, because you can always drop things and really mess up which polarity is which, I just go ahead and make a little Sharpie mark. I don't know if the camera will even pick that up. A little Sharpie mark on there to let me know that the dark side is what goes into the cave. You know, just kind of keep things as some sort of analogy in my brain so that I keep a system going and I don't end up in a situation where I glue this together and then have a magnet of the wrong polarity, and this doesn't lock together anymore. It tries to push apart in that spot and just makes it wobbly and not work the way that I want it to. I like to use super glue and activator for this. Make sure you always keep your super glue well away from your activator. All right, so I'm going to take my magnet off of there, pop it onto here. That was the wrong way, so that's why we mark them. Pop it onto here, so we've got, if I can get that to pick up again, we've got the mark there for the black going into the hole. And then you can just line it up, pop it in there, and then you'll pull this off. And that will leave the magnet in your hole. That way you're not getting super glue all over your fingers and you're getting it pretty flush. You can come back with a non-metal tool, a popsicle stick, a gloved finger, something like that. Come back, smooth that down to make sure it's actually flush, which, let me grab something real quick, I'll do that. You can tell I'm well prepared for this segment, having to go grab tools in the middle of it. All right, so you can take this, make sure it's flush, even use it to squeegee off a little bit of excess if necessary. Put that down on something you don't care about, and then take your activator and just hit it. And boom, now you have a magnet oriented the correct direction, flush, and my air compressor kicked on. Didn't even know I had it on right now. And then, let me cut that off real quick. Well, it timed out, just filling up the tank. Okay, so now we can test this. If I can do all this at once, be in frame. And that clicks on that magnet as it comes around. See that suction there? Suction. Well, you know, magnetic force, suction. We'll call it suction. Electromechanical, electro-suction, magnetic suction, magnetic attraction. That's the word. So, hopefully that tip will help you guys out.
Okay, so this is print test number 2. After I extended some things, redid some things. So here's basically a complete end cap. It is held together temporarily. It's not super glued. These are just kind of placeholders right now. As you can see, I've got some blue tape holding the pins in instead of the proper hardware. Everything's a little bit sticky because I haven't polished anything up yet. Oh, out of frame a little bit there. And I've only stuck that one magnet in that we did and a little bit of other hardware to try and test. Made sure that my drill template for the board is going to line up for the magnets, and it does. And first test, first time this has ever been a physical product. So from brain to hand, minimal reiteration needed there. And now holds all the pieces, so calculations were correct. Holds all the pieces for 6x6, and locks into place on the end cap so that when it's rolled up with the board, your pieces are more contained, pretty stable. Then if you want them off, just a quick little turn and off. So posts that line up, magnets that lock in, and I don't know if it'll handle a drop or anything like that, but for just your, everyday use, I think we're pretty good there. And now it's time to blaze through the rest of the project. So reprint all the pieces, print the pieces in the other color, the other end cap, hand paint both capstones, laser cut the gears for the scoring on each end, laser cut the board both front and back, and then a couple hours of assembly time and finishing, and here we are with our version 2. I want to thank you guys for watching today, and if you want to support this channel further, you can buy my books, you can take a look at my Patreon, you can get a commission from me. Just if you've got an idea for a board, pieces, capstones, something like that, even something off the wall, I'd love to take on your project and see what we can get done together. And as always, let's leave you with what we made today. Thanks, guys.